So, hi students, in this video we are going to learn the next chapter. We are going to enter into the next chapter of 11th grade math, that is the relations and functions. So, first of all, the relations and function little bit disconnected to the chapter 6, and most of the things, some operations of the sets will be applied from the previous chapter also. Okay, I'll explain each and every problem of that. Before that, I'll give you some basics regarding the chapter. Okay, the first exercise mainly depends on the definition of Cartesian product. So Cartesian product means what? Actually, what is a product? The numbers can be multiplied, the variables can be multiplied. Then what is the Cartesian product? It is specifically why it is called particularly like Cartesian product, because Cartesian product is the product of the sets. Okay, it's not the product of the numbers, it's not the product of the variables, it is the product of the sets. How sets are multiplied and how the result will look like. Okay, say first I'll explain you the definition with some examples so that we can write the definition. Suppose A is 1, 2, 3 and B is a set to some A comma B. Cartesian product is denoted with A cross B. A cross B means A is a set and B is a set, and A cross B is a Cartesian product. It is taken as the set of ordered pairs that can be written from the elements of the set A to the set B. See, ordered pair, the set of all ordered pairs. That means the first element will be from 1 with all the sets 1 comma A, 1 comma B. Next, element of first set with both the elements of second set 2 comma A, 2 comma B, 3 comma A, 3 comma B. Okay, so how you define that? The set of all ordered pairs formed from set A to set B such that x comma y, such that x belongs to A and y belongs to B. Always. The first element, suppose if it is B cross A, the first element should be from B and the second element should be from A. How it looks? A with all the three, A1, A2, A3. See, all the first elements are from the first set. Second elements should be from second set. Next, B1, B2, B3. And what you can say here, A cross B will never be is equal to B cross A. And what is the other note that we can note? How many order pairs you can make? The number of order pairs you can make in a Cartesian product depends on the number of elements in A as well as in elements in B. So elements of set A are 3 and elements of set B are 2. So it will be you are getting 6 order pairs in A cross B, and the same way B cross A is also 2 into 3 number n of A into, so the number of order pairs that can be formed can be taken as n of A into n of B, where n of A is the number of elements in set A, n of B is the number of elements in set B. So this is the set that we can make. Actually, if you see this carefully, then I'll go with the mapping, how these are mapped. Usually these are mapped like this. We represent generally with sets. It is not sure that we have to draw this in a type of circles or oval shape. It can be anything. A set can be represented like in a oval shape. Usually we write like that. 1, 2, 3, A, B. Cartesian product is taken as 1 to A, 1 to B, 2 to A, 2 to B, 3 to A, 3 to B. This is the Cartesian product. So if you take from A to B, we put arrow like this for all the mappings. So from A to B, okay? So no doubt in that. Now, what if they ask us to find out A cross A? Just we write A 2 times, 1, 2, 3 with all the mapping. How many order pairs we should get here? 3 into 3, 9. So 1 with 1, 1 with 2, 1 with 3. 2 with 1, 2 with 2, 2 with 3, 3 with 1, 3 with 2, 3 with, that's it. Okay. Now, one more important note. A cross empty set. So, how many elements we get? First we talk with that. So, usually A will have some 3 elements and empty set will have 0 elements. So, how many elements should we have? N of A and N of B? 0. So, it will be empty. A cross empty is always empty. Okay. Now, about ordered pairs. Suppose, what about the order pairs, sir? If any two order pairs are equated, suppose if it is x comma y, if it is 2 comma 3, something like that. So when any two order pairs are equated, when any two sets are equated, then always the first abscissa, this is called abscissa, should be equated to the abscissa of the other set. Okay, that means x value is 2 and y value is 3. This is important note in sets, sorry, in relations. Actual definition of relation we get it in second exercise. So let us start exercise 2.1 with the basics. We'll go with, and if anything is required, I'll tell at that moment when we start that problem. Okay. Okay, let us start exercise 2.1. See the first question. They given like this: x by 3 plus 1 comma y minus 2 by 3 is equal to 5 by 3 comma 1 by 3. Okay. So I told you just now, when order pairs are equated, we should equate the abscissa and the abscissa. Abscissa means the first coordinate. The x coordinate is called abscissa and the y coordinate is called ordinate. Okay. So abscissa should be equated. Plus 1 is equal to 5 by 3 and ordinate should be equated. So it becomes x by 3 is equal to 5 by 3 minus 1. X by 3 is 2 by 3. Therefore x is equal to 2. In the same way, y is equal to 1 by 3 plus 2 by 3. It becomes 3 by 3, that is equal to 1. So x value is 2, y is 1. Okay. Now the second question. If the set A has 3 elements and set B is 3, 4, 5, find the number of elements in A cross B. See, I told you n of A is 3 and n of B is, they have given 3, 4, 5 means they have 3 elements. So how many elements will be there in A cross B? This says that number of elements in A, number of elements in B, number of elements in A cross B will have n of A into n of B always. It is 9. Okay. Next, third question. If G is equal to 7, 8 and H is given as 5, 4, 2 and you are asked to find out G cross H and also H cross G. So G cross H, every element of A should be mapped with every element of B. That means every element of G here. 7, 5, 7, 4, 7, 2, 8, 5, 8, 4, 8, 2. That's it. So how many? 2 into 3, total 6. In the same H cross G, 5, 7, 5, 8, 4, 7, 4, 8, 2, 7, 2, 8. This is H cross G. Okay. Okay, fourth question. State whether each of the following statements are true or false. If the statement is false, rewrite the given statement correctly. Okay, let us see. The first question they have given, P is Mn and Q is equal to Mn. How many elements should P cross Q should have? It should be 4, but they have given only 2. Mn, Nn. Mn, Nn. What are they missing? M, M is missing. N, N is missing. So it is false and this is the correct one. Okay. It should contain 4 ordered pairs. See the second question. A and B are non-empty sets and A cross B is a non-empty set of ordered pairs. Both are non-empty sets. X, Y. X belongs to A, Y belongs. It is exactly the definition. A is a non-empty set and B is a non-empty set, and A cross B is a non-empty set of ordered pairs. And the ordered pairs such that the first element should belong to the first set, second element belongs to the second set. So second one is true. Third one, A is given and B is given. A cross B intersection 5. 5 means empty set. Let us see. So you are given A is 1, 2. B is 3, 4. You are asked to find out A cross B intersection empty. So let us find out B intersection empty first. B intersection empty. Empty means there will be zero number of sets. Empty intersection B is always empty. Okay, now A cross B intersection 5 gives A cross empty. So it has zero elements, it has some number of elements, two elements are there. 2 into 0, it will be 0. So 0 means number of elements are 0. If the number of elements are 0, we write the set as empty set, and empty set should be denoted like this. Okay? Right. So this is true. See, in the fifth question, you given A as -1, 1, and you are asked to find out the cross product like this, the Cartesian product like this. So first what we do? We do A cross A. A cross A. A cross A will be -1, -1 with -1 minus. It will be -1, -1, -1, 1, 1, comma, -1, 1, comma. Agree? Or if you are getting confused with this, you write 2 times. Then it will be easy. 2 times. -1 with -1, -1 with 1. 1 with -1, 1 with 1. Find A cross A. So 2 elements here, 2 elements here. You got 4 ordered pairs. Now A cross A. Here the ordered pair should be mapped with one more set. See how you get here. So this is an ordered triad. Triad means ordered pair means in a bracket you will get 2 elements. Ordered triad means in a bracket you get 3 elements. It is in 3 dimension. That means there are 4 elements here. We treat these as elements. 4 with 2 elements. Total you should get 8. Let us see how we get. This with first -1, -1 with -1. Ordered triad. Triad means 3. -1, -1 with 1. So with this 2 sets are over. Now with this 2 more. -1, 1 with -1. -1, 1 with 1. With this also 2 more are over. Now with this 2. 1, -1, -1. 1, -1, 1. Now with this 2. 1, 1, -1. 1, 1, 1. So total 1, 2, 3, 4, 5, 6, 7, 8. If you see carefully, there will be nothing repeated here in this. Okay? So when the pairs are repeated or when the ordered triads are repeated, we are not supposed to write in a set. That is the basic principle in the chapter 6. Okay? Next question. Okay, let us see here. In this set, you are given a cross product and you are asked to find out the sets. What is A and what is B? Always A will be the elements from the first element of a order pair or abscissa, all the abscissa. So what are the abscissa here? We have to write these in sets. A, no need to write it because in a set we should not repeat any element. B, then what is B? X, Y. Even X, Y are here, we don't repeat. See, when you take 2 here, total number of elements in order pair A cross B will be 4. Say it is 4. Right. 7th question. Okay, I got this. You are given A 1, 2, B 1, 2, 3, 4, and C 5, 6, and D 5, 6, 7, 8. And we are asked to verify this. A cross B intersection C will be equal to A cross B intersection A cross C. And one more thing also asked to verify. Okay, I will do here. Oh, let us see. First, to find LHS, we need first bracket B intersection C. What is B intersection C? It is empty. B intersection C is empty. So there is nothing common. So what is A cross B intersection C? It is A cross empty. It will be empty. Let us do RHS also. RHS. Let us do A cross B first. What is A cross B? Okay. 2 here, 4 here, you get 8. 1 comma 1, 1 comma 2, 1 comma 3, 1 comma 4. 2 comma 1, 2 comma 2, 2 comma 3, 2 comma 4. Now, what is A cross C? A cross C. 2 elements here, 2 elements here, total 4. 1 comma 5, 1 comma 6. 2 comma 5, 2 comma 6. So, what is A cross B intersection A cross C? What is common intersection among these two? There is nothing common, empty. So, LHS is equal to RHS. In the same question, they ask us to check if A cross C is a subset of B cross T. Verify. A cross C is here. Let us do B cross D also. Let us do B cross D. 4 elements with 4 elements. Total 16 we have to write. 1 comma 5, 1 comma 6, 1 comma 7, 1 comma 8. 2 comma 5, 2 comma 6, 2 comma 7 and 2 comma 8. 3 comma 5, 3 comma 6, 3 comma 7 and 3 comma 8. 4 comma 5 and 4 comma 6, 4 comma 7, 4 comma 8. Here we need to check whether A cross C is a subset of B cross D. Let us see. 1 comma 5 is there, 1 comma 6 is there, 2 comma 5 is there, 2 comma 6. Yes. Yes. A cross C is a subset of B cross D. What is a subset? If all the elements of one set are there in the big set, then this set, small set, is called a subset of that big set. Okay? Okay. See, in this question, you are asked to write A cross B. Okay, let us write A cross B. 1 comma 3, 1 comma 4, 2 comma 3, 2 comma 4. And we are asked to check. Next question is, how many subsets will A cross B have? What is the number of subsets? Suppose I write here. If a set is containing some n elements, 1, 2, 3, so on, n elements, number of subsets will be 2 power n. If a set contains n elements, this we have done in set chapter. So here how many elements we have? 1, 2, 3, 4. So number of subsets that we can make, that can be made, is equal to 2 power n, that equal to 2 power 4, 16. Next question, list them. Oh my god, we have to make all the subsets. Okay, I'll tell you. What are the subsets? Let us all list all the subsets, all 16. First of all, in a subset, what will be there? The same set 1, 3, 1, 4, 2, 3, 2, 4. This is a subset. We write S1, S2, empty set. These two are by default. Next, S3 will be single elements. S4, single element sets. S5, 2, 3. S6, 2, 4. Next, S7, 2 elements. 1, 3, 1, 4. How many 2 elements that can be made? S7, S8, 1, 3, 2, 3. S9, 1, 3, 2, 4. S10, 1, 4, 2, 3. S11, 1, 4, 2, 4. S12, 2, 3, 2, 4. Now, 3 element sets. S13, 1, 3, 1, 4, 2, 3. Subset, I am writing all the subsets where these elements are there in the big set. S14, 1, 3, 1, 4, 2, 4. Next S15. 1 4 2 3 2 4. S16. 1 3 2 3 2 4. That's it. I think we didn't miss anything. So these are the only 16 sets that we can make. You can check also. Okay. Say in this question, n of a 3 means number of elements in A is 3. N of B 2 means number of elements in B is 2. So in A cross B, we should have 6 ordered pairs. But they have given 3. They told that these are there in that set. These are there. From this, can you make the sets A and B? Yes, we can. All the first element should belong to set A, X, Y, Z. All the second element should belong to set B. See, n of A is 3, n of B is 2. Over. So total elements are verified. That's it. Next, last question. The Cartesian product A cross A has 9 elements. A cross A, n of A cross A is 9, and they told us which are found to be -1, 0 and 0, 1 are there in that set. So in that A cross A, -1, 0 and 0, 1 are there. So what is A they are asking? See, it is a Cartesian product made from set 2 itself. When set 2 itself, the order pair contains both the elements from the same set. Is it right? The first element should belong to A. Second element also should belong to A, no? Okay, because it is mapping from A cross A. So, -1, 0, 0, 1. 0 is repeated, but we should not write repeated numbers. So, when A is 3, 3 elements are there. N of A will be 3. N of A will be 3 there. A cross A will have 9 elements. So, it is verified. Okay? That's it. In the next video, I'll upload the next exercise. Bye guys.